Welcome to Brain Vision.
All right, so during a practice shot put throw, the 7 kilogram shot, world champion, 100 team, was left hand. The shot it is 1.7. Okay, so our final velocity, and let's just assume, let's make this really simple. This thing's going to accelerate in the x direction. Okay, I know that it's more complicated. There's really actually kind of an angled upward, but let's just pretend that they're accelerating this thing. Accelerating this in the x direction, right? And the final velocity is 13 meters per second, okay? And then they're saying that the distance is 1.7 meters, right? So this means that is the change in position, right? So x minus x naught, okay? And they want to all the physical quantities determined using this information. So let's just wow them here, okay? If we're figuring this out, right? Well, what I want to do is I think we can figure out the force. We can figure out the average acceleration, right? We could find the average velocity. Let's do that first, right? So our average velocity is going to just be the initial velocity plus the final velocity, right? Divided by 2, okay? So this guy is going to be what? Let's assume, we're assuming that it starts at 0, right? Okay. This is my assumptions, right? Okay, so that's one of my assumptions, right? Assumptions. That it all happens in the x direction. That the initial velocity in the x direction is 0. All right, those are some assumptions. I'm keeping track so far, right? Okay. So this is 0 plus 13 divided by 2. So our average velocity is going to be 6.5 meters per second. Okay, and that's what that means. A little v bar means average, right? I could write average too. Okay, so that's our average velocity. Let's figure out the acceleration. All right, the average acceleration. I'm going to use equation 1.7, okay, which says that 2 times the acceleration in the x direction times the displacement in the x direction, right? This is just the change in distance, right? So that'll be our 1.7 meters is Vx squared minus V naught x direction squared, right? Okay, so if we plug the numbers into this, we're going to go 2 times the acceleration we're trying to find, right? This change in position is 1.7 meters, right? And then we're assuming that the initial velocity is 0, so this guy is 0. So that equals 13 squared. And if we do some maths here, okay, if we solve this, right? So I'm going to take my calculator here. I'm going to go 13 squared. I'm going to divide by 2, divide by 1.7. And I get that the average acceleration, I'll put a little a bar over it, right? The average acceleration is about 49.7 meters per second squared. Now we only have 2 digits of significance here, right? So really you should say it's about 50 meters per second squared. And we could put a decimal point on that, right? So that is yet another quantity that we figured out, right? And then we can also figure out the force, right? The force, the net force we can get from Newton's second law. And this is just the net force. Okay, what the total, like there could have been the force of Earth acting against it. That's a little more complicated. But we know the net force is, all right, net is equal to ma, right? And we know that the mass of the shot is a 7 kilogram shot. So that's the other thing we know. The mass equals 7.0 kilograms, right? Okay, so we can figure this out, right? Our mass is 7.0 times about 50 meters per second squared. That gives us 350 newtons. And that's the average force, basically. The average net force. That's our average acceleration. What else can we do with this? That's it. I think we better stop. We've gotten the, right? What were our assumptions? The initial velocity was 0, that it all happened in the x direction. We could assume that the acceleration is constant, right? If it's constant, then this is exactly true, right? That is the acceleration, that is actually this, right? It would have to be a constant acceleration too for this to be true. So that is also another assumption. The acceleration is constant. It's not a tentative assumption, that's an actual assumption. What else? All right.